Thanks for your invitation to present this story about production of Tier 3 ultra-low sulfur gasoline. The presentation is in three parts: the business case, laboratory studies of octane destruction, and commercial field tests. To understand the business case, we need to talk about two things. They are gasoline sulfur and octane. Gasoline sulfur reduction toward 10 ppm has been slow in North America. This chart shows the U.S. average ppm sulfur in gasoline for the last 10 years. We see it's been going down at about 2 ppm per year, and it needs to reach 10 ppm sulfur by 2020 in order to meet the EPA's Tier 3 gasoline sulfur requirement. This requirement was set into law in 2014, and the industry has had 6 years to prepare. And you see the approach to this has been rather slow, and we still have a big gap of 24 to 10 ppm to fill. And I would point out that we are currently in the middle of 2018, so this gap must be filled in the next 18 months. The problem is that gasoline desulfurization causes octane loss. So as we move to 10 ppm sulfur, octane is going to be destroyed for reasons that I will explain. And that is going to reduce the octane supply capacity of North American refineries significantly. And the price of octane is going up. I snapped these pictures yesterday in Wheaton, Illinois, where I live, near Chicago. The price of 87 octane was $3.18 per gallon, and the price of 93 octane was $4.18 per gallon. This is a $1 differential, and many of us are more accustomed to a differential of like 10 cents instead of $1. Here's a chart of the U.S. premium minus regular retail price differential showing that octane demand and price continue to rise. This is a chart over the last 20 years. Historically, the differential was 10 cents per gallon. In 2005, it started going up, and it has continued to increase. And as of the end of 2016, where this chart ended, it was 50 cents per gallon average in the U.S., and it's continuing to go up. So this is the business case for our work. We believe an octane sulfur squeeze is coming. We've been predicting this for the last 3 years. Because we have this gap, 24 ppm down to 10, that needs to be filled by 2020. That's going to be accompanied by octane destruction, a reduction in octane supply capacity of North American refineries. Meanwhile, octane demand and octane price are up. This is the formula for a squeeze. Next, laboratory studies of octane destruction. The first point that we need to recognize is that 98% of gasoline sulfur comes from one stream in the refinery. It's called fluid catalytic cracker gasoline. That stream accounts for 98% of the sulfur in gasoline. It is about 1/3 of the volume of gasoline, but almost all of the sulfur in gasoline. So clearly this is the stream that we need to deal with in order to reduce gasoline sulfur. These are pilot plants in the laboratories of AIChE Solutions in Thessaloniki, Greece. We used them to study the desulfurization of gasoline. And these are essentially small-scale versions of the same units that are used in refineries to desulfurize gasoline. And here is a chart of some of the results from our laboratory test. This is a chart of gasoline octane versus gasoline sulfur. As we move from right to left on the chart, we're increasing severity of the process to reduce the gasoline sulfur. And we see what happens is that the octane goes down the further we go down in gasoline sulfur, and the octane loss accelerates greatly as we go deeper and deeper in desulfurization to meet and go below 10 ppm. The normal operating window for the process historically has been in the upper right of this chart, and in fact even further right than that. But for Tier 3, we are going to have to push the process out of this normal operating window much lower, and we see here that that's going to be accompanied by much greater octane loss. Now, commercial field tests. This is about tests run on actual gasoline desulfurization units in refineries. And we do what we call a blood test, which is a very detailed analysis of the gasoline as it goes through the process. And this is a chart from the blood test of the distribution of olefins in the gasoline. Olefins are a type of compound that are high octane, typically around 100 octane. And in the desulfurization process, they are destroyed. So we see the gray curve is the distribution of olefins in the feed, and the orange curve is the distribution of olefins in the desulfurized product. The gap between the two curves represents olefin destruction, which means octane destruction. The olefins are converted chemically to paraffins, which are very bad for octane. So in this commercial unit, making low sulfur gasoline resulted in 7 octane loss. The industry had been expecting an average of 0.5 octane loss. Now this is in blood tests on another commercial unit. This unit is designed differently to preserve light olefins and not destroy them. Still, this unit saw 25% olefin conversion and 2 octane loss. But this shows that a relatively straightforward and low-cost modification to the unit can preserve much of this octane loss. Our 3-year study of this topic is helping our clients decide Tier 3 gasoline strategy, capital investments, process design, catalysts and licensors, and something I didn't have time to talk about is sulfur credit strategy. And our study covers all aspects of the issue, including the regulatory part, the economics, as well as the technical aspects that I've discussed today. The conclusions, our business case shows that an octane sulfur squeeze is coming. Our laboratory and pilot plant tests show that octane loss will be more than is anticipated. And our field tests and blood tests show that capital investments are needed to mitigate octane loss. Thanks a lot for your attention, and I encourage anyone interested in this topic to contact me anytime. If you're interested in this topic, you really should have our report. All of our work is available to anyone at a small fraction of its cost, because this is all a shared cost, multi-client program. And I've shown you today only a small part of the information we have to help with this topic.